Hello and welcome to another free code session. My name is Jason Bach, and we're going to continue building this source generator, AutoDeconstruct. As I was reading my notes, I realized that what I said here is that the second pass will just return the node. The real work will happen in the source output method. And this again is this whole like incremental pipeline passing that you're doing with an incremental generator. Does it make sense at this point to do a lot of work with the with doing any kind of transforms or investigations on your node? I was thinking about this right before I hit the record button. Does it make sense to try to figure out, do we want to generate with this type a deconstruct method or not? Or does that make sense to do in the source output? This is really, I'm starting to think about this and going, maybe what we want to do is figure out, do we actually create a, do we do here the determination of that we're going to create a deconstruct method, and then in the actual method to do the generation, we know we're in a good state. As I'm thinking about this, I'm like, yeah. I'm thinking that the second pass, we won't just return the node. What we're going to do is return a type symbol. And that type symbol is a type that we want to generate a deconstruct extension method for. Okay. Now we also need to be a little smart in what we're going to return, because we don't just want to return the type symbol, because what we need to do in here is find all the accessible properties, because that's the ones that we want to create a deconstruct method for. Okay. So the thing though is that we don't have to really worry about types. We just need to find the accessible properties by count, because deconstruct methods, you're overloaded by the number of out parameters. That's it. You're not, you can't do like overloads by types or anything like that. That's not the way deconstruct methods work. So what we can do here, I think now that I'm thinking about it, that's probably the right approach, is to filter them out and give the types back here. We don't necessarily need to give the list of properties, so long as like we just get the count here, and then when we go into the method that does the generation, and then we'll actually get the property names, because we're going to have to do one little twist there as well. So in any event, let's move on. So the second method here, yes, we're going to be changing it up a little bit from what I said before, which is we're going to have this transform targets method here. We'll grab that, and then we're just going to return a named type symbol, or probably just a type symbol. I like name type symbols because those are a little bit nicer. Yeah, probably a name type symbol. They give you a little bit more information. But in any event, we're going to have another private method here. Okay. Static. And we're going to have it return a I type, we'll say named type symbol, transform targets. Okay. So now in here, now this one doesn't bark anymore. Okay. But now here, what we need to do is say, what are we doing in here? Transfer. Yes. So in the context, we get a node. This is, now that I think about this, this is probably why I said in the actual final pass, this is where we want to do it. And the reason why is because I want distinct nodes. This is only giving you, if you look at the context here, context.node, that is one node from here. So here you're saying, is the given node one that you want to look at? Yes. Now in here, you can say, let's do some more work, and you can actually get from the context here, the semantic model, which is why you can do more things. Sorry, I got a little bit distracted. My wife texted me and I was like, I didn't know what she was getting at. So I I had to stop recording for a second to answer. All right, so you do get the semantic model, but this again is only for the one node. And to actually figure out whether we're going to do deconstruct, we actually want to get all the nodes. So that is why here I'm just going to say syntax node transform targets, and all we're going to do is return context.node. Okay, that should work. Okay, and again, the reason why we're doing this is because we need to do a lot more work looking at the entirety of what we're doing in our project as best as we can. Just looking at the type itself, like if we get a type symbol node, and that's a type declaration node, we don't know if we found a method declaration syntax node that has a deconstruct for exactly the number of accessible properties. So we can't do that here. We're still looking at one node at a time. We need to have all of them. Okay. So the next thing we're going to do is we're going to copy and paste, because copy and pasting is a good thing. And we're going to come down here and we're going to say combine, I think, compilation provider, combine provider collect. That gets you, yeah, we don't, this analyzer config options provider, the reason why I'm putting that in here is because I do allow you to create a configuration file in a way, so that I can look for it to say what types of names do you want to have in play. And I might do this at some point with AutoDeconstruct, but for now, all I want to do is collect all these things. Okay. And so what this gives you when you do this is an incremental value provider of basically the compilation, which is on the left, and on the right is an immutable list of all the syntax nodes that we just found up here. Okay. So then we can say register source output here, where we're taking our output, and where did we get output? That actually is what we want to have here, because we don't have another combine approach going on just yet. And so we're going to have a create output here that we're going to say just source left and source right. Okay, and we don't need this. We're just going to pass in this context. Okay, so register source output from the actual the generator context way back up at the top here in initialize. If you look at the register source output, honestly it's a little bit confusing to look at here, which is you get a it's really difficult. You get a source, and you also get if you look at this, you get a compilation left, you get a right, and that is the thing that's being passed into you as the source, and then you give it a action. It's one of these methods that, you know, what I'm trying to do here is, I think I was trying to say is actually, yeah, you get the source and then you provide an action with your source production context. It's basically what you're trying to do is say, I want to create some source. So if I look at my context here, that's a source production context. If I look at my source here, this is the left and right part that we got from our output. So we have a compilation and an array of all our syntax nodes. If I come back over here, this method here is kind of what we want to do. So we're going to have a private method where we're going to have a compilation, and then, oh no, wait a minute. That's the first. Yeah, then we want an mutable array. Is it an array? Is that what comes out of here? Immutable array of syntax node. Yeah. Nodes. Okay. And this is now where we're going to start to do a lot of our work. You don't know what an immutable array is? You do now. Okay. So we have a source left, we have a source right, and then we also want the source production context, which is the last thing we're going to get. Okay. All right. So again, now we're at the point where we filtered out as best we can all the syntax nodes of what we think we want to look for. We've now done all the things with the incremental generator to do these combines and collects so that now we have a list of all the nodes that we filtered from here. Okay. So now what we need to do is a little bit more work. We need to get a distinct list of all type nodes that we found before. And we want a distinct list of, I think method declarations, I don't think matters. And actually, if I think about this, the type declarations, the only way that we would not get that we need to worry about with distinct is if we had partial types. So we had the declaration here and a type declaration here. And so what we actually want is a distinct. But if I think about it, we actually want to maybe, yeah. Yeah, this is one thing that I did not think of. And I've never actually thought about this with any of the types I've actually ever created, or any of the things I've ever done with source generators, which is, it's possible if I did this, for example, if I said like public partial class foo, okay, and then I did public partial class foo, that's okay. And if I go to the syntax visualizer, you know, I could do something like this, where what it's going to do is give me a class declaration. We want to see, you know, well, you could see and look at the modifiers and do you have the partial keyword in here? But then you also would have that here as well. So what I'm saying is you could have multiple definitions of a type where one would have a deconstruct method and the other would have a deconstruct method. Isn't this fun? It's, you know, but this honestly is what you have to think about when you're creating these source generators, which is what are all the possible things that a developer could legally do in C# that maybe you don't do that. I don't think I've ever created, you know, partial types on purpose, much less have multiple partial types that have deconstruct methods in multiple definitions, and they all get mashed together. But again, you're at the compiler tree level here. Okay. You're not at the, how do I want to say this? You're not at the, let's mash all things together and come up with the answer. Now, one thing though, that I did not think of is, let me switch to a different, nope. Recent projects and solutions. And that is, I want to actually open up rocks, because in rocks, that's something I said, yeah, I definitely want to do, because I could get multiple definitions. And I don't know if I've ever actually really solved this with rocks. This probably sounds like a lot of babbling. This is definitely not a great way to do a tutorial on how to create source generators. But if I come down here and I go to rock create generator, and I eventually figure out, is this, see here, I'm actually taking the node and then I return for that node a type symbol. I put that into a tuple. And then I come out here and I get all of the distinct type symbols. Now here's the thing I'm not necessarily sure about, is the target here is a type symbol. If I say target dot, and if I say declaring syntax references, get the syntax nodes where the symbol was declared in source. Some symbols, for example, partial classes may be defined in more location. This property should return one syntax. So I think by just seeing this, the way I'm reading this is that you can, you know, for a given symbol, you can have multiple nodes where it's been referenced. So probably what I want to do is, if I just, you know, saw what I did here, which is good because that means rocks, I'm doing the right thing, is I want to find all of the type declarations, get their symbols, and they get a distinct list of symbols from that. Because then I know I don't have to worry about partial types. The symbol actually puts all the partial types together. That's the way I'm reading this. And I could be reading this wrong, but you know, that's the fun of all this. Okay, so No, let's go back to rocks because I think that actually is doing what I want it to do. Yeah, so we want to go symbols, which is the syntax node symbols, and we do a distinct here. That actually may not be quite correct in that we want to, now that I think about this, this may not be quite correct because I may have, and I'm going to make a note of this because reasons. Rocks distinct on the syntax node and a type symbol. Is that good enough? Because what could happen is I could actually have two type declarations and they resolve down to one symbol, but because of the way I'm doing it here, I'm actually doing a distinct on the symbols, which is an array of both these things. So to do a distinct here, it might actually only do a distinct based on the combination of both, which is not what I want. I want to actually have a distinct on the symbol itself. And then do I really even care about the node? I kind of do because, you know, you can see here I'm actually, why? Context dot, shouldn't you get a model here? Oh, you don't. Oh, that's right. So that's one of the weird things here is that you don't actually get a semantic model. So you actually have to go get that for that particular node. So yeah, I'm sorry, this is really not turning into a tutorial at all. This is this is really getting to be kind of a pain. So semantic model for a tree. Yeah, that's just what you're getting. Wait a minute. Compilation. Why doesn't the compilation itself have a semantic model for a given tree? Yeah. Oh well. At some point you have to give it a tree, and that tree comes from a node, and that node is a syntax node. And for the specified syntax tree. Now, though, if I come up here, the context has a specific semantic model, but that semantic model was given from the node that you have. So I might be way overthinking this because I definitely want to get distinct symbols, and I don't really care what type what syntax node it comes from. I think I might just say pick the first, and that gets me a semantic model. Now I think about this more, what I might want to have come out of this is actually the syntax node and the related semantic model out of it, because then I just have that here, or get the symbol related to that node. Tune in next time. I'm going to think about this off camera as to where I want to go with this next, and see what do I think the right thing is to capture here, so that when I get back to the create output, I have the right thing and what I'm doing. So I'm going to stop here. So next episode, I will have thought this through a little bit more, and we will hopefully be getting to the point where we can actually start generating code. I know this probably feels really laborious, and it is. Doing syntax generation, I've found and it might be because I'm not doing it right, but I found that you really have to think through a lot of things that you just don't necessarily think about when you're writing C#. Trying to, in a way, parse it and deconstruct it, no pun intended, is sometimes a little difficult, and you run into things thinking, how would this actually really work? So that's what I need to do off camera. But next episode, I will have thought this through, and we'll have more to work on. So thank you all for watching. Leave comments and questions below. See you in the next episode.